All right, today we are going to run through some angle measures in both degrees and their corresponding measure in radians, just for additional clarification, and then we're going to get into reference angles in regards to degrees. So looking at the four quadrants here, we discussed some terminology in the previous lesson where the positive x-axis here is often referred to as the initial side, and then wherever the angle, the amount of rotation ends up, that side is called the terminal side. So if we had a very simple angle like it starts here and then opens maybe to here, maybe this angle is 60 degrees, this is your initial side, that's your terminal side. But what I want to look at right now is the relationship between the quadrantal angles in radians and degrees, because these will be very important moving forward. So if an angle, if the initial side and terminal side were here, if there was no opening, we would probably call that 0 degrees, okay? But if we rotated here, we know that this angle right here forms 90 degrees. If we continued that rotation, another 90, that would be 180, another 90 would be 270, and another 90 would be 360. So one full revolution around the unit circle is 360 degrees, and it takes us back to where we started. Now, you can see I have radian measures all the way around as well, and what we can do is use our conversion factor between degrees and radians, where we multiply by pi over 180. So if I did 90 times pi over 180, 90 over 180 is 1 over 2. So half a pi is the same as pi over 2. So you can see I have pi over 2 here. If I did that same math, we could get these other angle measures in radians as well. So pi, 3 pi over 2, and 2 pi. Those are the equivalent radian measures for the quadrantal angles in degrees. Okay, so that'll be important for us again moving forward. Now we're going to transition to reference angles, which I referred to in the previous lesson. The reference angle will often be noted by theta prime, okay, and it's going to be really important for us finding sine, cosine, tangent, and their reciprocals, all right, those values. The definition of a reference angle is it's the angle formed by the terminal side in the x-axis, all right. So everyone's favorite is when the angle is in quadrant 1, because in quadrant 1, the reference angle and the angle that you're given are equivalent. So if I had a 45 degree angle, it looks something like that. Well, that meets the definition for reference angle already. All right, the x-axis is here, the terminal side is here. So that's good to go. So if our angle is 45 degrees, our reference angle would be 45 degrees, okay? You can see though, when we move into different quadrants, it will be different. So here in quadrant 2, we have a 150 degree angle. So this is theta right here, 150. That's the amount of rotation from the initial side to the terminal side. But that is not a reference angle. A reference angle, again, is the angle formed by the terminal side and the x-axis. So in this case, the reference angle is actually this pink angle that I have outlined. Now I have that measured at 30 degrees. Well, why is that 30 degrees? Well, back in geometry, we learned that a straight line has 180 degrees, and these two angles right here form a linear pair. So to figure out what's left over here to basically complete that 180 degree angle, you could do 180 degrees minus 150 degrees, and that will give you your reference angle, theta prime, of 30 degrees. All right. Moving on to quadrant 3, we can see a similar scenario here. We have a 250 degree angle, so it's rotating past the 180 there into quadrant 3. Similar but slightly different here. In this case, if we need to figure out the reference angle, again, the reference angle is going to be the angle between the x-axis and the terminal side, okay? So we need to figure out this portion here, which I have marked as 70. Well, again, how did I get 70? Well, if I just want this portion here, I just got to take away this part here. And what's that part worth? It's worth 180. So what I can do is take 250 and subtract 180, to get my reference angle of 70. Okay? So again, we just had to take off this part here because I just want this portion right here. Into quadrant 4, 320 degree angle, so that would be this amount of rotation here. So again, this is theta. All right, to get theta prime, which I have marked as 40, we need to first consider what the reference angle is. Again, the reference angle is going to be the initial, or the angle formed between the x-axis and the terminal side. So I need this portion here. We know that one full revolution is 360 degrees. So if this is 320, what would get us all the way around to 360? Well, another 40. Okay, you probably can do that in your head, but if you needed to do that mathematically, really what you are doing is taking 360 and subtracting off what you're given to get that 40 degrees. All right, so if the angle that we are given is between 0 and 360, we can use the following rules, all right, by the quadrants, okay? So we can utilize these formulas, which is basically what we did up here. So if the angle is between 0 and 360 degrees, if theta is between that, these are the rules you can use to find the reference angles.